think it's this one. Right, you all looking at Math 99 module, blah, blah stuff. Can you all see that? Right. This is our Canvas course. This is essentially what we have on Canvas. If you click on that, it'll tell you a little bit about myself. There we go. Some interesting videos. I come from Scotland, so I think I've probably told you. And nothing too surprising there. The important thing is you need to join WebAssign. The reason you need to join WebAssign is that all the homework is there, and that's where your book is, your textbook. It's in the form of an e-book, an electronic book. Now, if you want to join it, you click on this, and here is our class key, and this thing here will slowly take you through the steps. The class key, that's this thing here, essentially lets you into our WebAssign. We have one WebAssign class that's for only this class, and it contains all the things that you need. And you see it in here. This is how you log on. Now, if I go through some more things on this, there's a thing here called Adobe. I'll talk about that probably closer to the time. You don't need to worry about that right now. And that's for when you do exams, your midterm and your final. Because what you're going to do is you're going to do them on paper, just like you would do in the real world. And that is a piece of software that you put in your camera and you take a picture of your stuff and it turns into a PDF and you send it to me. And I'll give you the details. But if you watch this and look at these two, you'll find out how to do that. Since you're all here in Zoom, I figured out that you figured out how to do Zoom. If we now move on to the second one, office hours are 10 AM every day. Now, the fact you've got an evening class, that might not work for you. So this is an alternative for you lot. I tend to come in about 10 minutes early and I'll hang about at the end. So if you have any questions that you would have wanted to do in an office hour, just come a bit earlier and ask me, or wait till the end and ask me. I think that's probably more realistic for you. But I mean, if you've got a whole day off, there's the office hour. It's just a Zoom link. Click on it, and it's a bit like knocking on my door. I'll let you in, and you can ask your questions, and I will help you. And if I scroll a little bit more, what we have here is essentially some resources to help you. For instance, if I click on this one, it's techniques for solving what are called systems of equations. And these are not my videos. These are videos by other professors at OC or just people I found online that are quite good. And the reason I've got that resource there is I might think I'm great. Since I'm Scottish, we all think we're great because we're arrogant. I know I'm not. And it might be helpful for you to watch someone else describe the same topic. And you might say, yeah, that makes sense to me now, because the way I did it might not. And I'm okay with that. This guy here, for instance, is Craig. He's a professor at OC. But there are other people here that I do not know where they come from. This is a resource. The green number is how long the video lasts. So this little one here takes 2 minutes and 54, and this thing's over half an hour. So you kind of know what you're committing to if you decide to look at a video. And I've got, oops, I should go back in there. Not only do I have things like videos to watch, here's a PowerPoint. Some people like PowerPoints. And down here, hopefully, these are my notes. These are things that I've written. And they're basically, this here, for instance, just is a revision of the coordinate system. And then it progresses on to drawing lines and all sorts of cool stuff. So everything I've kind of spoken about for the last 5 to 10 minutes on Canvas, they're just help things, resources. You can choose to look at none of them. You can choose to look at whatever you're stuck at, right? So if everything working's great, you know, you're getting the homework done, you know what you're doing, you might not look at it. But if you're getting stuck, wouldn't this be just another place you can go to try and get unstuck? Right, so you're not doing that, well, okay, I just don't know how to do it, I'm just going to ignore that bit and move on. And that's not good in math, because, you know, if you don't know how to do A, doesn't B kind of very often need you to know how to do A so that B will work? It's very sequential. So it's not a good idea to let things kind of simmer. And there should be a third topic here. And I'm going to leave student view for a second and find out why not. And it wasn't highlighted. That's why not. And the third one is general college information. So we have tutoring, totally free. There's a resource for you. Stuff to do with Canvas, institutional policies, COVID stuff, tons of cool stuff, right? So again, I think the theme here would be things that you can use that would help you. Right, so far so good. Is there any questions about what we've looked at in Canvas? Are you happy about what's there and why it's there? So if you want to go and look at it, you can. It's your choice. Right, I'm now going to move over to the syllabus. Hopefully it's there, and it is. I looked, I think about 5 of you have already joined WebAssign, which is really good. So the rest of you get started as soon as you can. First thing to talk to you about is contacting me. Will you use my OC email, right? drobertson@olympic.edu. When you're in WebAssign, I believe there's features like Ask the Professor, and you click on it and you type in a little message and it's meant to ask me stuff. And there's another one that you click on it and it's ask for an extension or something like that. None of them ever get to me. They disappear into the ether, and there's probably a place where I could redirect them to me, but I've never found it. And even if I could find that place, knowing the OC email server, it would probably block it as spam, so I'd never get to see it anyway. So the bottom line is, don't contact me through WebAssign. So if there's something in WebAssign saying, click this and you can talk to me, you can't. Ignore it. Just go into normal email and send me it the usual. You can do it in Canvas, right? You can talk to me in Canvas, send an email there. That works fine because that is linked directly to my email. So that was just a little thing that I mentioned, which is what that sentence there is trying to say. Maybe I could make this a little bit bigger, and how big your screens are. Does that help? Maybe a little bit. Prerequisites to get in the class. I can and sometimes do change when something is due, because we may need more time or less time. Here are all the things that you need. Excuse me. Bailey, come on. Come on, boy. Oops. You good? One of the joys of teaching at home is that your dog doesn't know that it's meant to be quiet. He's probably telling me there's a bird on the deck or a leaf just went by the window. It's very important to him. And my wife should really be keeping him quiet, but I don't know where she is. So hopefully it won't distract you too much, and he'll eventually get fed up trying to tell me something. So where was it? Right. The equipment that you need, in particular, we've talked about the webcam. There's help desk if you have issues. Here's another link, resources. Sing is a resource. You click on that, it's the Student in Need group. And sometimes they can help you financially with, you know, things if you have a real problem with that. Here's the class key again for WebAssign. We got these guys here are important dates. So today, on the 26th, there will be no class, Monday the 26th of April. That's just the day I'm going to be missing. That's going to be my personal day. I've got some things I'll be doing that day. The rest of the college is on. So don't think that means all of the college is closed, so your English class is cancelled as well. It's not, it's just my class, that's all. So Monday 26th is just me. Moving on, there is an important day. There's your midterm. Monday, the 14th is the last class day. That's actually going to be a revision day where we'll just get, you know, over topics, getting you ready for the final. And our final is 5 to 8 on Wednesday. So these are really the important dates. There are not many to keep track of, which is kind of useful. What we have here is the work that you're going to be doing, the homework assignments, essentially. You're going to be doing these topics for the first 2 weeks, and they're due midnight on Sunday. You're going to do these topics 3, 4, and 5, so that's a 3-week period essentially, and that's going to be due on the 2nd. There's that midterm again, and that's going to be on everything we did in the first half, as you'd expect. And then we do a 3-week chunk. That's these topics there, up to topic 17. Homework's due on a Sunday. Then we do these topics, homework's due on a Sunday. So homework is due Sunday the 18th, Sunday the 2nd, Sunday the 30th of May, and the last homework is due on Sunday the 13th of June.
I have a quick question for the second week. It says April 2nd.
Yeah, it could be a typo. Let's see.
Oh, go down. In week
Oh, here?
Yes.
Yeah, I'm sure that's the 5th of May.
Okay.
But thank you. I'll try and take a little note of that. Yeah, that doesn't make sense. Pretty sure it's the 5th of May. But I'll double check. Oh, Monday's the 5th of May. No, Monday's the 10th. 5th, 10th. Yeah, it's probably the 5th of May. Anything else about that? Are we good? Right, moving on. Okay. 10% of your grade is for turning up to class. There are 20 class days, 10 weeks, technically 11, but there's 20 days in which you can be here because of holidays and me being missing. And you get 10% of your grade. So every day is 5 points, if you like. 100 points if you do perfect. And if you come up, 10% of your grade right off the bat. Now, homework, which we just went through, is going to be worth 20% of your grade. Your midterm is going to be worth 30, and then your final is going to be worth 40. So you can see that there are going to be a lot of points for the midterm and the final. But not coming to class is not a good idea. Well, one is you won't get to see the work, and secondly, you've already lost 10% before you even start if you didn't turn up. So not a good idea. It's a good idea to do homework. We'll talk a little bit more about it, but it's your way of practicing the topics, getting good at them. It's also your way of figuring out, do you actually know it? Because you might see me describing something and you'll nod your head and say, yeah, I can do that, that makes sense. But sometimes you think you know what's going on, but once you see the homework questions, you realise that maybe you don't know it as well as you thought. And it gives you a chance to find out what your weaknesses, if any, you've got. Midterm, going to be a PDF. We'll talk about that closer to time. Final's going to be a PDF. We'll talk about that. And there's 2% extra credit. So if you've missed a couple of days attendance, you can actually gain that back by doing extra credit. And the extra credit is you just take a free intro to Canvas class. Now, some of you might have already done that class. If you don't know what it is, here's some of the information. Go and do it. It doesn't take long. Send me a copy of the certificate. If you've done it, just send me the copy of the one that you did last year, and you get 2% added on your credit. If you miss some days, well, even if you don't miss days, you still get extra credit. If you have problems, here are some of the college technology links. Then you've got your grades, add them all up. This stuff you read in your own time. And we are done. Whew. I know it's a lot to take in, but are we good so far? Right. The last thing that we need to concern ourselves with is going to be WebAssign. I don't know if that switch over worked. Did that switch over work? Are you now looking at WebAssign, or will I have to go out and in? Node means you're looking at WebAssign, right? Okay. So let me show you what your WebAssign will look like. Hopefully, there we go. This is what your WebAssign class will probably look like when you go in. These are the homework assignments that you have got to do. And over here, do you see it tells you midnight essentially on Sunday? Just like it said in that list, you know, 2 weeks do this, 3 weeks do that, right? So you can see here, it's just duplicating the information. Think of this as normal homework that you do in a book. You just write your answers on the screen rather than a piece of paper. So to give you an example of what that might look like, homework 1 is just getting you used to WebAssign. So you just go in there, I'll click on it, see what we get. And yeah, it's kind of silly, but that's okay. It's just showing you how you answer things. So there's a question. Select your response by clicking one of the option buttons. To change your answer, click another one. When you're ready, click Submit Answer. Okay, select the option called This is the correct answer. Well, I'm going to put that one. Oh, wait a minute, I changed my mind. I want that one. Okay, I'm happy with that answer. Submit answer. Ooh, I got it wrong. What's going to happen? Nothing. You get 5 shots at every question. So you go back and you go, I like that answer then. Ooh. I like that answer then. Yay, I got it. Right? Now, normally your work won't look like that. Normally you just pick the right answer, hopefully, and you've got it right. Now, some answers you pick from a pull down. Some answers are, which one of these is correct? And guess what? It's told me. See a little billet? Make sure I picked it. There we go. Hit submit your answer. Now, in normal homework, you get 5 shots, right? 4 times you can be wrong, then you get the 5th shot, right? So it's not like it's immediate, you're out of it, right? Oh God, I meant 12, not 22, that's it, I'm wrong. No, if you meant 22 and you type 12, don't you just go back and put in 22 and then submit it again? All that WebAssign does is keep track of the final correct answer, right? So if you get it right and it takes you 4 shots, or you get it right and it takes 1, it doesn't really care. Right, now if you want to type in square root, you click on that and you got a little guy over here, and then you type in X. And then submit answer. I mean, so far, would you agree it's pretty intuitive, right? You got an answer, you type in. Now, if the answer's 42, oh, there we go. And that one's a fraction, but let's pretend for a minute. If the answer was 42, do you know you just write 42 in the box and that would be it? If the answer is false, you just type in the word, right? If that was what you had to type in. And these guys here are pretty good, but I want to show you how to do those in a few minutes. So essentially, you go through your homework, and when this kicks back in, and you will have all of these done by Sunday the 18th, midnight. Do not wait till Sunday 10 p.m. and think you're going to get all 5 sections done, because you won't. Plus, that's not a good way to learn anything. I suggest that once we do a topic, maybe not tonight because you're probably tired, but sometime tomorrow would be a good idea, and that you do the homework questions that are relevant to what we've covered, right? So if we've covered how to solve a system of equations using the elimination method, you should be able to go back and do those homework questions, and that gets you practice. And it also gives you a chance to shoot me an email and saying, hey, can I have an officer? Because I'm not getting these right and I don't know why it's not working. And maybe it's just a little thing we can fix. Are we good with how WebAssign works? How you do the homework? I got the nod. Did you know you were doing the nod there? Now that I've talked about it? Right. Now, down at the bottom, we have 2 textbooks, College Algebra, Basic Journey, right? So if you click on, say, this one first, it's an ebook. It's a bit slow, I apologize for that. But essentially, it's a textbook just like normal textbook, it's just online. And if you wanted to find out about systems of linear equations, you'd click on that. And if you wanted to look at some practice, you click on that. And it gives you some questions with the answers and little pictures, which is a little bit different than the normal textbook. Normal textbook, it's there or it ain't there, right? But here it's a little bit more adaptive. And you can, just scroll through it. It's a resource, right? It's something for you to look at to help you. And that is me finished the intro. Is there anything that I haven't covered or you'd like clarifying? This is your chance to ask a question.
Would this be, because when I went to make an account or log into it, it says that, so I have a free trial.
Yes, the free trial, that's glad you brought that up, Sarah. Not that anybody's going to do this, but you might have to because, life gets in the way. Rather than having you committing 100 and whatever it is dollars to do it, I thought it was 2 weeks, but maybe it's 1 week. Is it a 1 week?
It's about 2 weeks.
Right, you get a 2-week free trial. Some of you haven't got your financial aid yet, right? And all that good stuff, right? So you do the free trial version, and you've got 2 weeks to get your money together, right? And then at the end of 2 weeks, it's going to say, look, you better pay or we're bumping you out. And we don't want that, right? So you've got 2 weeks. It might be that you take this course and you think, I don't understand what he does. He is not the guy for me. Well, haven't you at least not forked out $100 odd that's now gone to waste? Because you've still on the free trial and you quit, right? Now, I don't want anyone to quit, but it's helpful. So you haven't got money because the financial aid hasn't kicked in, and it gives you the chance to leave without really committing too much money to it. So If you've already forked out the money, sorry, but I think I put in the instructions somewhere, if you go hunting for them, that there is a 2 weeks free trial thing. You might not have noticed it, but if you go looking back to Canvas, you will find that I said that somewhere. And if you're going to stay for the whole course, it won't matter, right? Because you need to pay it. So it's not like the end of the world. But thanks, that was a good one. Any other questions? Right, some just came to me. How do I keep track of who's here? Well, the way I keep track of it is that you lot are going to say hi towards the end of this class. You're just going to type it in as text, hi. And I copy that response, and then I use it to do a register. So Sarah and Dawn and Rachel, I know that's your names, and that is true. But if there's 2 Sarahs, which I'm scanning through here, I can't see 2 Sarahs, but maybe next time you can call yourself Sarah Smith and Dawn Robertson, and that'll just make it a little bit easier for me to figure out who you are. So I know it's a bit nitpicky, but it just makes my life easier. Right. Anything else before we get started the work proper? We're good? Last chance? Okay. Let me darn it in space. You can't do things when you want to do it. Oh, there we are, my home. Okay, it's kicking in or not. I don't want to go there. Go away. That's better. Okay, everyone, let's get started then. Our first topic is going to be linear functions. So just give you a little heads up. What is a linear function, for instance? Right. A linear function is typically a function that's written like y equals 2x plus 5, y equals minus a half x minus 7. It's essentially a straight line. Linear just means straight. So it's a straight line function. And when you get a function that's written in the form y equals so many x plus a number, we call that the slope-intercept form. And what you might know, hopefully you do, is that you can also have straight lines written with this version of the equation. You know, like 2x plus 5y equals 10, right? That is still a straight line. And if you plot all the points that have this relationship or that one, what you get is a straight line. So for instance, not that pen, it's not. If you take the equation y equals 2x plus 1, that's called the slope-intercept form. The number that's next to the variable, in this case the 2, that is going to be the slope of the line. Does anybody remember what the plus 1 is? And it's kind of in the name. Any idea what that plus 1 is? Last chance.
Isn't it like if it's on a graphic line, it goes 1 up?
It's the x-intercept.
Almost. You got the word intercept right. It's the y-intercept.
Okay.
But you were there. You were in the ballpoint. Now we want to draw those guys. That's what we're looking at right now. How do you draw the straight line with equation y equals 2x plus 1? Mathematically, we might phrase it as draw the function y, or draw the linear function y equals 2x plus 1. But it's the same thing as me saying draw the straight line y equals 2x plus 1, right? It's just different words to mean the same thing. Essentially, the method that we're going to use which I'm going to call method 1, is we're going to find 2 points on the line. And then once we know those 2 points, we'll plot them, and then like getting a ruler, we'll draw a line right through them and we're finished. That's how easy it's going to be. So what kind of 2 points should we get? Technically, any 2 points at all would work, but when the equation is written in this form, I would choose an x equals 0, and that would give you a y coordinate of 2 times the x coordinate plus 1, and that would give you a y coordinate of 1. So if you imagine me putting this together, and I'm making no attempt to be very accurate here, but when x is 0 and y is 1, doesn't that get you the point with coordinates 0, 1, which is there? And that's what we call the y-intercept. So essentially, when it's written this way, one of my 2 points is going to be the y-intercept. So what do I do for the second point? Well, I typically will choose x equals 1. Why 1? Because I'm lazy and I like little numbers, right? 1's a nice little number, right? A wee number. I could check, couldn't I choose x equals 411? Would you agree that would be a pretty dumb value of x? Because I'd need a huge chart just to plot the darn thing. So keep it small. So what's the y coordinate going to be? 2 times the x coordinate plus 1. That's going to be 3. And that gives me the point 1, 3. So can you imagine that's 1, 3, right up there. And there's my 2 points. And then can you imagine using a ruler? I draw a line that's meant to be a straight line, by the way, everybody. And we would normally put y equals 2x plus 1. Now that's how you would have done it back in the olden days when you were in class and I was in front of the whiteboard, or you were sitting at home and doing your homework from the textbook, right? You'd have probably square paper as well, right? And you do it like that. So how are we going to adapt that to do the same question on WebAssign? Right? So let me show you how that would work. This is going to disappear in a minute, but if you just remember these 2 numbers, these 2 coordinates, it should come out fine. So I'm now going to go to WebAssign, and we're going to pretend that that was one of the questions that they had in WebAssign. So graphing linear functions. Click. There we go. And here we go. So imagine the question up here was graph f of x, because that's what they like, equals 2x plus 1, right? Just pretend for a minute it said that. So how do you do it? See this little guy over here? You click on it. I record this lesson, and it will eventually be in Canvas, and you'll find it on Canvas. So if any of these buttons, oh God, which one did he press again? I know he pressed one of them, but I can't remember which. You can go back and just look at that piece of the video and say, oh, okay, I got it. Right. The one that you pick is the one with the 2 arrows. So you click on it. And my 2 points were 0, 1, which is what, here. Let me do that again. Click. 0, 1. There we go. And 1, 3. Hey, it done. Do you see how it joins the 2 dots up, and I got my line? And if that had been the right question, I then go submit answer and we're finished. So do you see that when you do these kinds of questions, you're kind of doing it in 2 different places? Didn't I have to do all this stuff on paper? And it was these 2 coordinates that I used to draw the thing on WebAssign. So I don't need to draw this, although if I did, it would make sense when I look at my picture. I'd say, yeah, that kind of looks like him. I must be doing it okay. Are we good with that idea of how to draw a straight line that's in this format? Okay. So as long as these numbers are nice numbers, to me, nice numbers are 3x plus 2, 5x minus 7, right? Things that look like that. This technique will work fine. But there's going to be situations where the slope is a fraction. You know, like 3/4 x plus 1, 2/3 x minus 7, minus a half x plus 2. I'll probably do a minus a half x after this one. When it is, if this, look, when it looks like this, we're going to use mostly the same method, but I'm going to call it method 2, because there is a change. This is the bit that's the same. We're going to find 2 points on the line. Oh, by the way, we're going to find 2 points on the line no matter what the method is, right? Because you're going to find lots of different methods depending on what this equation looks like. So we're going to find 2 points on the line. And the first one is exactly the same as that one. Choose the y-intercept. So when x is 0, the y is 3/4 0 plus 5. And so that gets me 0, 5. That's good. Now, this is where you have to adapt. I could pick x equals 1. If I did that, wouldn't the answer be 5 3/4? 5.75. Would you agree that's a bit clunky and might be quite hard to get accurate? Right? How good are you at finding 5.75 on a box that's that big? Aren't you probably going to get 5.6, 5.8? You're going to put it in, it's going to look fine to your eyes, and WebAssign's going to say, you're 0.1 out, you're wrong. So what you do in these questions, when the slope is a fraction, forget about the numerator, the top number, doesn't matter. Focus on the bottom number. Do you see how that's 4? 3/4, it's 4. Why am I picking 4 instead of 1?
Cancel out the denominator.
Yeah. Isn't that going to get me a nice y coordinate? Let's see it happen. Right, it's going to be 3/4 the x value plus 5. Now, do you see 3/4 and 4? They kind of cancel out, and you get 3, add 5, and you get 8. And that gets me 4,8. Now, here's, this is a good point for me to pause for a minute. When you did your normal homework in the good old-fashioned old way, hopefully you kept your notes and you kept your homework so that when you were getting ready for the exam, you could go back and you could say, you know, what did I do? Oh yeah, I can see what I've done. You know that WebAssign doesn't keep almost any of that information. So if you go and look at WebAssign, won't you just see a straight line? And you'll think, I don't know how I did that. So it's very important that you remember to hold on to your homework working. And this is for your benefit, so that when you go back and look at it, you can actually see where you got these 2 coordinates. Because if all you do is see those 2, couldn't it be quite easy that you've forgotten what you did to get them? Right? You know, I wonder where those 2 points that are in that line came from. I'm not sure, or at least where that one is. Now, once you've got that guy, I'm going to just do one more return to the screen and pretend that we had a homework question that was like that one. Right, I'll use this guy. Oh, perfect. Can you see the version they've got up there? That's right. I know I'm going to do the one I've got, but since that's there, x equals 0, I would pick that one. You agree? That's why I always choose. And that would get me the point 0, -9. What x would I choose the second time if I was wanting to do that one? Well, I could choose x equals 2, couldn't I? And that one would get me -18. And I'm looking at this and I'm saying, oh, darn it, I can't get -18. There are ways around that, and I'll show you later. So let's pretend that that wasn't the question, because I want to show you method 3. You know, you need 3 methods, and that would be an example of it. The 2 points that I got are going to be 0, 5. So I'll click on that. Gotcha. And I've got 0, 5, which is what? Here. And 4, 8, which is here. Now, let's say that I'm a bit shaky with my hand and I accidentally put the dot there. Right, can you see it's wrong? If you go over here, do you see you can change this number to 8? Whoops. Yeah, do you see how it fixed it? So if the points were kind of weird and wonderful, now I don't think it's going to like this, but I'm going to put this in anyway. Can you imagine that that was my answer? Right? I'll try that again. See what it does. Yeah, it's not going to take it. So it's only going to take points inside that grid, right? Just fine. You don't want huge numbers that are not in the grid. But if your dots are a little bit out, and I'm just randomly picking some places for this to go, can't you go over here and double check that the points correspond to the ones you wanted? Just because I can imagine a 9.1 happening when you really meant a 9. Could you imagine you could be just a tiny bit out? It's a bit hard to see in your eyes, but you'll be able to see it over here. Are we good? Right, now I have one last technique to show you, which is going to be called method 3. And let's look at that guy. And I've forgotten to do what I always should do. I should pause for a minute. Are we happy about method 1 when everybody's a nice whole number? Like 2x plus 1 and 3x minus 2. Are you happy about it when there's a fraction here but a number there, right? Like 3/4 x plus 7, right? That kind of thing, right?
So would you always want to use the bottom denominator?
I would.
Okay.
Unless, that's why we need method 3, I end up with a point that is outside the window that WebAssign does, right? You know, when WebAssign looks like it only picks -10 to +10, right? Can you imagine I might get 4,20? Wouldn't that wouldn't fit, so I couldn't use it. Now, that I wouldn't need to worry about in the real world. Wouldn't I just do a bigger graph and put the point in anyway? Right, I get it to fit. Couldn't I draw my own paper graph and plot the point, you know, 4,20, right? But since I'm restricted to the windows on WebAssign, we need to create a third method, right, to make it happen. So actually, I've got that guy. So why don't I just use him? It's the same situation. Right? It's a fraction, the negative doesn't matter, and a number. And you're going to choose, oh, this is going to be method 3. And we're going to choose as our first point, x equals 0. And what that's going to get me is y equals -9/2, nothing. Take away 9, which is -9. And that gets me the point 0, -9. And that's okay, right? I can get that on WebAssign, right? Doesn't WebAssign, as long as the numbers are 10 or less, it'll fit. If I chose x equals 2 here, which is what I would have done up here, do you see that I'm going to get, well, can you just trust me that if I chose x equals 2, I would get that? Now, there's nothing wrong with that, except I can't plot it in WebAssign. Did you see how WebAssign wouldn't let me plot it? So I wouldn't be able to put the line in and answer the question. So we need a workaround. How do you make it happen? So you would probably do 2, and if it works, use it. And if it's too big, right, it just doesn't fit, we resort to this method. And how do we do that? Well, I'll show you it visually because it's probably the easiest way to do this. Here is that point, right? 0, -9. I know that this, this has a slope. And the slope is -9/2, right? So what I need to do is I need to start at this point, and I need a slope that basically points down the way like that, agreed? And this is a bit clunky, but it's the kind of the only way we can get around this. Hopefully it doesn't happen often enough. Can you remember that to calculate the slope, you do rise over run? Can you remember rise over run is the slope? Now, in this question, it's -9/2. The run is how much you go left or right, and the rise is how much you go up or down. And the fact that it's a negative number means I'm sloping this way, not that way, right? That's how we tell negative slope, pointing down the way, positive slope, up the way, right? Now, I want you to keep that in your head for a minute, because the next bit I have to go back to WebAssign and show you how we get the second point. And what we do is we use the slope. And I've got this guy here. Let's start again. There. Now we have our first point, which is fine, which was there. Now I want a rise of 9 and a run of 2. Remember, it was -9/2. I want a riser, right? I want to go up and down 9, and I want to go left or right 2. Now, since it's going to point downwards, I'm going to go 2 to the left, and 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you see where I got that guy? Rise, run, 9/2. Do you see it? 9 up and down, 2 left or right. And do you notice that it's pointing down the way it should be, right? A negative slope. If it was +9/2, right? +9/2 x minus 9, wouldn't the only difference be I'd be over here? Now you see that's a little bit clunky, but you know, whoops, you have to do what you have to do. There. Now, I am now going to submit answer, and I've got all my fingers and toes crossed here. You ready for it? Go. See that insignificant little green tick, little check mark? Doesn't that mean I did it right? So method 3 involves us using the slope to help us to get the second point. The reason I don't use it for all 3 methods is that it is a bit clunky and harder to do. Isn't it much easier if you just have 2 points and join them up? 2 points, join them up, right? I find it easier to do it that way. And I leave method 3 for the ugly ones with fractions that don't fit, or just downright messy things that I'm having a real hard time with. And then I use the point slope trick that we just showed you. How are we doing? Are we feeling good about that? Do you want me to do any more of those? Because this is you kind of taking over for a minute. Would you like to see another ugly fraction one, or are you good with the one we did?
Can you do method 3 one more time?
I like that. Okay, I'm going to just zoom over here and see if I can pick one. God, would you believe it? There's virtually none. Ah, gotcha. Well, actually, that one would work with method 2. That'll work with method 2. You can't see what I'm saying. That'll work with method 1, method 1. Oh, darn it. Okay, I'll just make one up, right? But I've just scanned through all the homework, and there's only one of them that really method 3 needs to be done. But that doesn't mean that you shouldn't have practice at it. So let's do a positive version. 4/3 x take away 3, right? Now, I'm going to choose x equals 0. Can I skip a whole load of working? Because haven't you noticed that when x equals 0,
We
the
can't
y
see
coordinate?
the video.
I can see it. So, I mean, that's all that matters. I'm the one that can see it. You're just being awkward. Yeah. Okay, here's the equation. Do you notice that the x equals 0 works for everybody, right? So we kind of know that's going to happen. What I'm doing here is, you might do the whole working thing like I did here for a few shots, but have you noticed that the y coordinate is just -3 when x is 0? Doesn't that basically disappear? So couldn't you do that in your head without having to write any work? Do you see what I'm getting at? So 5/7 x minus 9, isn't the guy here going to be -9, for instance? Now, the slope in this case is 4/3, right? So the rise is 4 and the run is 3. So won't that be up and down 4? Agreed? And it's going to go left or right, 3. Now, since it's a positive number, don't I want the one that points that way? I'm kind of just visualizing what it's going to look like. So I'm going to have a point, and I'm going to go 3 that way and 4 that way, right? And can you see it kind of looks like 4/3, doesn't it? At least when I draw it that way. So I'm now going to go back to WebAssign and try and draw 4/3 x minus 3 and see how that works out. Come on, there we go. Okay, the y-intercept was -3, so click on that guy and gotcha. And then it's going to be, what was it? 3 along and 1, 2, 3, 4 up. Can you see my 3 along and 4 up thing? And there's no point in me doing submit because the one they want is this one, but can you see it working? You ready? You feel comfortable about that one now? Right. Now, let's clear some of these off the screen. And I'm going to go and go through some homework questions at the start. And essentially just say what technique I would use. You know, method 1, x equals 0, x equals 1. Method 2, x equals 0, x equals whatever the denominator, right? So if it's 3/4, x would be 4. If it was 5/7, x would be 7, right? I would use that technique. That's method 2. And then method 3 would be x equals 0 and use the slope, right? So that's a very concise version of the 3 methods. Would you agree that question 1 is method 1? can we just do x equals 0 and x equals 1 and it would work fine? What might you do for question 2? X equals 0 and x equals what?
5.
5. And that one would fit, so you could use method 2. How do I know it's method 2 or 3? Isn't it because there's a fraction here? Okay, this one's really not that question. This one is, here is the guy. Which one of these 4 guys is it? Since it's here, let's do it. It's 3/4 x plus 4. Would you agree that they all should cross the y-axis at 4? So that means I can forget about these 2. Agreed? They don't cross the y-axis at 4. So it has to be one of these 2. Since it's 3/4 x, would it be the one on the left or the one on the right? And I don't need to even think too hard about it. Which one of those 2 would be the 3/4 x plus 4?
Left.
The one on the left.
This one here? Okay, let's look at why that might not be the case. Do you see that 3/4 x? Doesn't that mean the slope is positive 3/4? Which one of these lines is positive slope?
The
The
right
right
one.
one.
The right one. Agree?
Mhm.
Yeah, gotcha. So this one, you would just go pick that and you're finished. See how quick that homework was. Now, back to this guy. Oh dear. Isn't this the one where we had to use method 3? Because it just didn't fit. Wouldn't this work perfectly fine with x equals 0, x equals 1? So that would be method 1. What about this one? What method would we use? 1, 2, or 3? Agreed. 1. Hey, that's a good idea. Just stick your finger up means I get more than one answer. Would you agree 1 again? Yep. I'm getting bored now. 1 again. Okay. Yikes. Isn't that going to be method 2 or method 3? Yeah, 3 would work. So would 2, by the way. So you know how that sometimes more than one method will get you the answer? That's okay then. Don't you still get the right answer? Does it really matter if you did 2 and somebody else did 3? No, doesn't matter to me. Ooh. What about that one? 2, I agree. I think it works with 2. Yeah, it does. Could you use method 3? Sure. I tend to avoid 3 because I think it's harder. That's the only reason. But 2 and 3 are almost interchangeable, aren't they, in many questions? You could do either. Wouldn't that be probably 2, but you could certainly do it 3, or actually you don't need to because this is pick the guy. Oh, we're back to method 1 again. And yeah, that one would work with method 1 as well. Okay, pause there. We've kind of done half of the sketching of linear functions. We've essentially found out how to do linear functions that are the slope-intercept form. Do we feel comfortable about drawing those guys now? Do you feel you know the strategy for drawing them? Okay. So we're now going to look at the second kind, which is how do you sketch linear functions? I know they might not look like linear functions, but they are. When they're written in this format here, they're called standard form. So there is an example of a straight line being written down in its standard form. Now, what's the shape to it mathematically? I'm using the word shape. Isn't it so many x's plus or minus so many y's equals a number? That's basically what it looks like, right? Now, when you have a straight line written in that format and you want to draw a graph of it, right? You need 2 points. Agreed? You need 2 points. And here we go. This is method 1. you should get deja vu here. Uh-oh. I think I've done this method before. I'm choosing x equals 0. And I'm going up here and I'm saying 2 lots of x plus 6 lots of y equals 12. Do you see that the difference is that you have to do a little bit more work? Essentially, don't you have to solve a little equation to get the y value? And that gives me 0, 2. So far, so good. Now, this might not be so obvious, but once you've seen it a couple of times, it will become obvious. What do you think I'm going to pick as my next choice? And it might not be x equals anything.
2.
Oh, I could. And would it work? Actually, it would. But I'm not going to choose that. So nothing wrong with that, because it would work. I'm going to choose something else. And it's not an x equals anything.
Is it y equals 0?
Yes. Why do you think y equals 0 might work well? Can you see it's going to be quite a nice number? At least in this question. Now, what does that tell me? It says 2 lots of x plus 6 lots of 0 equals 12. So 2x plus 0 equals 12. By the way, I think it was Rachel who went and said x equals 2. Was it you, Rachel? Yeah. Do you know what method 2 is going to be? Pick x equals 2 or something, right? So it is a valid technique. In this case, eventually you get this guy, and now you've got 6, 0. To save some time, can we pretend that I went over to WebAssign and done the dot thing? Are we comfortable about how to do the dot thing? And if I did the dot thing, wouldn't I do a 6, 0, which would be here, and a 0, 2, which would be here, and then WebAssign would do the rest, right? And we'd be finished. Now you notice 0, 2 is the y-intercept and 6, 0 is the x-intercept. So this method is very often, if you look up the internet, is finding the intercepts method. So you basically find out where the line crosses the x and y axis. And provided that the numbers are nice as they are here, right? Nice, easy to plot numbers. This method works totally fine. Now, sometimes it doesn't work quite as well as you'd like it to, which is why Rachel's x equals 2 thing would kick in. So let me pick an example of where that might happen. Oh, it's going to be hard to pick one off the top of my head, but here it goes. 3x plus 4y equals 6. Yeah, okay, that might work. Okay. If I tried to do that one using this method, it actually would probably work, but let's just do the choose x equals 0. That becomes 3 lots of 0 plus 4y equals 6. That's 4y equals 6. That is 6 over 4. That's essentially 1.5. So it could work. Would you agree? Right. That method could work. On the other hand, if I decide to choose, say, x equals 2, don't we get 3 lots of 2 plus 4 lots of y equals 6? don't we get 0 plus 4y equals 6? Oops, sorry. 6 plus 4y. 4y equals 0, y equals 0. Do you see that gave me a slightly nicer answer? Right, when x is 2, the y value, 0 just happens to be what this one ends up being. It could be 10 or 42 or something. So in method 2, essentially, choose x or y to be any numbers that work. Now, what do I mean by any numbers that work? Would you agree that x equals 2 gives me a point and it's easy to plot? Now, you're going to be generous with yourself. That is not impossible to do, right? I'm going to show you me plotting 0, 1.5 on WebAssign. So let's nip over to WebAssign and show us doing that. So don't get caught up with, oh, I must do it this particular way. There is a lot of flexibility in how to do these, right? It's very likely that you could find the 2 points that you're looking for in a number of different ways. Now, if I wanted to plot the point 0, 1.5, wouldn't I click somewhere about here? And I'll try. Well, I can't even drag it down with this darn thing. Which is not a bad thing, right? I think it's got this feature where it tries to jump to the nearest whole number. Now, I'm going to put in my second point, which I haven't actually done yet. So let me pick another point. I should have probably done that earlier. 2, 0, right? Wasn't that the other point? Now, boom. Now, if we go over here and I click on this guy, wasn't this guy 1.5? Do you see that's how I fix it? So I can put in awkward points, and sometimes I might be able to get one good point like 2, 0, and one ugly point like 0, 1.5. What's going to happen if it's 3/10? Well, won't you call it 0.3? If it's 7/5, won't you call it 1.4, right? You know, you'll be able to work with it. I'm just try this out. I don't know if it would work or not. Yeah, it might. Let's try it. 3 sevens. Type in 3/7, right? So if you ever had to plot a really ugly one, couldn't you also do it? So that's nice that it can cope with that. So method 1 is make x equals 0, find out who y is, and then make y equals 0 and find out who x is. Are we cool so far for those questions? Now I'm going to show you some examples of that, and then show you that we need another method. Now, do you see how they're saying x-intercept and y-intercept? What are they doing? They're telling me that they want me to do method 1. So you put in 0, 2, and what was the other answer? 6, 0. So do you see that they're forcing you to do what I called method 1, right? And then you would go down here and you'd plot the point 0, 2, just here, and 6, 0, which would be here, and everybody would be happy, right? So if you see x-intercept, y-intercept, you don't have a choice. You got to do method 1, right? Now, I don't know if this is going to work. Is that helping some of you on small screens? Does that mean then, has it got bigger? Not much, okay. Oh, come on. No? Okay, I'm going to have to show you what I was wanting to show you. I think the situation I'm talking about is not going to happen until the next section. So I'm going to kind of jump ahead a little bit and show you why you need a third method. So here goes. Imagine that you got a really, really ugly equation written like this. And you wanted to graph this guy. Could I do x equals 0? Could I do y equals 0? Yes, I could. And that would work. And I'm going to show you method 1, doing it with that, and showing that it would work. And then I'm going to show you method 3, a different technique for solving the same problem. So method 1, you find the x and y intercepts. So you choose x to be equal to 0. Now 3 upon 2 nothings plus 2/5 y equals 1. 0 plus 2/5 y equals 1. Okay, what would I need to do to both sides to find, what would I need to do to both sides to find y?
Multiply by the reciprocal of 2/5.
Yeah. And so the answer is 5/2. And that would give me that fella. Or 0, 2.5. Now, don't we know that you can actually plot that in, right? We've shown you that you can do 2.5s. Bit ugly, but you can do it. So that would be our first point then, wouldn't it? Now, if I choose x equals, not x, if I choose y equals 0, then I get 3 upon 2x plus 2/5 y equals 1. That gets me 3 upon 2x plus 2/5 times nothing. That gets me 3 upon 2x plus 0 equals 1. And now I'm putting in more lines than anybody would ever want to do. I could do that. Now, wouldn't that be, I guess as a decimal it looks like that, but wouldn't that just be 2 divided by 3, right? 2/3. So our second point would be 2/3, 0. Now, can you imagine then I just went to WebAssign and I do 0, 2.5, which is here, and I do 2/3 thingy bob, and it's here. And wouldn't WebAssign, couldn't I use over here to tweak the numbers to make it work? Do you want me to show you me doing these ugly guys on WebAssign, or is it okay for me just to say you could do it? Would you like to see it or not? No great demand either way. I will show you then. So can't use that one. It's got stuff on it. Let's use this one then. And I want to do 0, 2.5. Well, I'll try and do 0, 2.5 about here. Of course, it didn't work. And then I'll try and do 2/3 0, which is about here. Of course, it didn't work. Then you go over here and 0, 2.5 and 2/3, 0. Do you see how you tweak it to put in the ugly guys? And that method works totally fine. That is essentially, isn't that us just doing our usual method, right? picking X is 0, then picking Y is 0. So I'm now going to return and show you method 3. Okay, I'm having technical issues because you lot are now in the way of where I need to be. Go away. Got a little window. There we go. Close it and go in. And it's a little bit algebraic, or a lot algebraic. What I'm going to do is multiply the equation by 10. Now, 10 times this guy gets you 15x. 10 times this guy gets you 4y. And 10 times this guy gets you 10. Mathematically, these two things contain the same information. What's the difference? Would you agree that these are easier to deal with because there aren't any fractions to get in the way? And then you just use the usual method 1 or method 2, whatever method you like, and you're good to go. So method 3 really just involves getting rid of the fractions. And that is sometimes useful. The number 10 wasn't just a random number. Do you notice that this is 2 and this is 5? So if you use 10, these go away. Let me randomly pick one. Suppose it was 3/4 x, take away 1/3 y equals 2. What would I multiply everybody by here to get rid of all those fractions?
12?
Yeah.
Okay.
And 12 times that would get me 9x, and 12 times that would get me this. Well, somebody's little kid is joining in. You know, if other people join the class, they have to pay a fee. So that little kid owes me at least, I don't know, 20 cents right now. So I'll claim it later. Right, and now once you've got it like that, can't you use any method that you like to get the answers? Don't always expect nice numbers, right? 2/3 and 4/5 and 5/7 are going to happen, aren't they? Right, and that's okay when they do. That is us finished our first section. Is there any questions about what we've done so far? Do you feel comfortable about drawing equations of straight lines that are either slope intercept or standard form? We're going to do more of it in the next section, but right now we go.
I have a question.
Yes.
So the one that we just finished, the 9x minus 4y equals 24.
Yeah.
Does that also have to be graphed or no?
We're assuming that these are all going to be graphed. But that's okay. If you wanted to graph this one, you could do it, make x equals 0 and y equals 0, which is method 1. Or you could play about with, you know, x is 2 or y is 3, you know, pick some numbers that might work. I'm looking at this one and I think x equals 0 would work well. I think I'd have a problem with my next one. I'd probably pick x equals 0 and maybe x equals 2. That would be my choices if I was doing this one. But actually anything will work as long as you're careful. Right. Now, there was a question that came out of the blue. So I didn't even know it was here. So I'm going to talk about it just for a few seconds, then we'll move on to our next section. I don't think it's a biggie. It's this question 15, which is essentially the last question. Do you notice that there are 4 equations here and it's asking you for M and B? Now, when you write the equation of a straight line, it's y equals mx plus b, right? So it's slope-intercept form. So the answers are really staring you in the face. 9x, slope is 9, plus 8, the b is 8. Now, if you need negative a third, enter a fraction. So I'm going to assume that I can do negative a third and negative 4. Whoops. Would you agree this one is what, 1 and 1? And what's this? Oh, this is interesting. What's the slope on the last one, D? What number is the slope?
-1.
Agreed. What makes this one a little bit weird is, what's the value of B?
1.
Not this time, no. Look again.
Well, there's no B.
There is no B.
Oh.
Yeah. 0. Agreed? Right. So that was just a little, whatever reason that was tagged there, that's fine. Let's move on to our next section then. I think I have to hit home. Is that good? Home. Yes. And we're going to look at solving system of equations by graphing, by essentially drawing the equations. So I'll click on this guy. Okay. And let's do some notes before we go near the homework. Let's talk about what's called a system of equations in mathematics. Technically, it's called a system of 2 equations. Well, if I do the equation of a straight line in standard form, it looks like this. And if I do another different straight line, it looks like that. And when we're being asked to solve a system of 2 equations, we're really being asked to solve what value of x and y are both these going to be true at the same time. Now, if you only take the top equation, won't you get a whole load of points on a straight line, maybe that straight line there, right? And if you take the second one, won't you get a whole load of points and you'll get a straight line going that way? But can you see that there's only one place where both of them agree at the same time? That point where my finger is, right? That's called the intersection. So when you solve a system of 2 equations, what we are trying to do is we're trying to find out what unique point, hopefully it's a unique point, you get when you have 2 equations, 2 straight lines, and you're trying to match them together and find, is there any common point, any combination of x and y where this is true and at the same time this is true? That's kind of the big picture, right? That's what we're after. So what can happen? A number of really nasty things can happen. Let's look at the good thing that can happen. I'm making no attempt to draw this correctly, but couldn't we have 2 straight lines and they meet at a point? Now, if that happens, there will be one solution. And again, I'm making this up, and the solution could be at 1, 2, right? For example. Right? Can you imagine a situation where this was the first line and this is the second line? In other words, couldn't both lines be parallel? That's a fancy word for that. Now, if they are parallel, are you ever going to get a place where these meet? And in that world, there will be no solution, right? That's your answer. No solution, right? It's an answer. You might think I've covered every possible thing that could happen, but there's one situation I haven't covered yet. It's quite hard to draw, actually. But here goes. Can you imagine that that is what the equation of the first line looks like when I draw it? And when I draw the second guy, whoa, he ends up being the exact same guy as the first one. This is probably the weirdest of the three situations. If both lines end up being the same line, right, equivalent lines, how many solutions are there to the problem?
Is it
Infinite.
many?
Yes, infinite. I think that little kid is agreeing with me.
Sorry.
Is that yours, Rachel? Is it? Can we see her or him? I think it's a her. If you want to, you don't need to. It's your child. You want to see her? There, come on, let's see her.
Come here. Come here. They want to see you. Come here. Ooh.
Oh, you're a
Can you say
biggie.
hi?
Oh, little guy.
Say hi.
Hi, little guy.
No.
No,
Say hi.
that was it. Okay, bye-bye.
Bye, baby.
Okay, so there are going to be three situations. And our goal in this section is to draw these two equations, draw these two lines. And if we see a picture like that, we're going to write down the coordinates of the point, right? 1, 2. If we do a picture like that, in the box, we're going to write the word no solution. And if we see two guys on top of it, we might write infinite solutions, right? So that's kind of the big picture. That's what we're going to be doing in homework assignment, I think it's called 3. Before we get there, they've got a kind of early version of that question where they give you an equation. And I'm going to actually use my version of question 1, that way it's consistent. They have 4x take away y equals -13. And the other line is 3x add 2y equals -7. So now I'm going to be accurate about it. And they ask us to check, is the point -3, 1 a solution? And all you're going to do is pick yes or no. Now, since you get 5 shots at every homework question, can you realize that if you're being unscrupulous, don't you just hit yes, and if it's not correct, you hit no and you move on? But if you do that, aren't you going to have a problem with not really understanding what you're doing? You're just taking the easy way out. So we want to be able to find out whether this is, yes, you are a solution to this pair of equations, or no, you're not. Now, if you think of that, that's the x is -3, and this means y is 1. So here is my check. I'm going to call this equation 1, and I'll call this guy here equation 2. So I'm going to check with equation 1 first. It says 4 lots of x take away y should be -13. So that's 4 lots of x take away 1 should be -13. And good news, yes. But shouldn't I also check the second one? Because it might not work with the second one. So I'm now going to check it with equation 2. And equation 2 says that 3 lots of x add 2y is -7. And that's going to be 3 lots of -3 add 2 lots of -1. And that's -9 take away 2. And that's -11, -7. Would you agree that's a no? So won't that mean then that no, it's not a solution? For it to be a solution, shouldn't it work for both? Shouldn't it be a check, it works, another check, it works again? Does that technique make sense to you? Does it seem obvious? Yeah, that makes sense to me. That's how I could check. So all you're going to do is you're going to plug x is this number, y is that number into the first equation. Does it work? into the second equation. If both of them are check marks, you will say yes. If one of them, it doesn't matter if it's one or both, won't you say no? And the question's finished. Any questions about that? Are we good?
Couldn't you use that same equation or method to double check on your work if it's right? Or
I'm not sure what you mean, Jenny. Jamila.
no, I was thinking something else. Never mind.
Okay, that's good. You thought it through. That works. So there's a couple of homework questions, numbers 1 and 2, where that's true. And I'll go back to my notes here.
No, thanks.
Right. When the two straight lines, I'm just trying to get the jargon sorted out here. See, when you have two straight lines crossing, right, they're different. The word that we would say here is that these are independent equations. Can't spell dependent. So that's going to be the jargon word when that happens. Right. When they are parallel, as they are here, they are going to be inconsistent. And when they are on top of each other, they're going to be equivalent. So if you draw them and they look like that, you might, you'll probably be asked to find this point, but you might also be asked to do that. Inconsistent or equivalent would be in the other two situations. Okay. Got that out of the way. A little bit of jargon. Let's solve our first question. This is like homework question number 6. I have x plus y equals 9, and I have, darn it in space, I'm getting tired. Let's do that again. X plus y equals 9, and I have x take away y equals 1. And it says solve this system equation by graphing. And it talks about simplifying your answer and then see example 1, objective 1. Very often in these questions, they make reference to things that you can find in the textbook. So if you go and look at the ebook, you'll be able to see example 1, objective 1, and it will be an example of a question like this, just to show you how to do it. But I guess since I'm showing you how to do it, you might not need to do that bit, right? So we are going to solve this system of equations, and we're going to do it graphically. And that means we're going to do it all on paper. Sometimes you get questions where you actually do it on WebAssign and you can see what it looks like. But in this question, you're going to do it totally by hand. So the only answer that you're going to have here is a little XY equals, and they have a big box and that. And so our answer, if it exists, is going to go in here, if it's numbers. And if it doesn't work, I'm going to say inconsistent or equivalent, right? Or phrase like that. All right, let's take our first equation. I could probably do that one in my head. I'm going to use method 1. Would you agree if you make x equals 0, it crosses the y-axis at 9? And if you do it, y equals 0, it crosses the x-axis at 9, and you do a straight line. And now I've just realized I have a problem that you won't. If you are really going to draw these on paper, wouldn't it be a good idea to use square paper? Because you want it to be accurate, right? Unfortunately, I don't have any square paper. So you're going to pretend I'm really accurate and we'll see it working. Right, let's look at x minus y equals 1. Okay, I want to draw that guy. Give me, tell me how I can draw this equation. Tell me a method I might use. You agree it's standard form? Right. Could we use method 1, which is just the x and y intercept trick? That makes sense? Right, so instead of doing it the quick way, I'll choose x equals 0. So this becomes 0, take away y equals 1, negative y equals 1, y equals negative 1. That gives me the point 0 and negative 1. And then I'm going to choose y equals 0. And so that's going to be x take away 0 equals 1. That's going to be x equals 1. That gives me the point 1, 0. So I'm going to put in 1, 0 and 0, negative 1. And we got that. Now this is the bit I'm going to have to cheat. If you do this on nice square paper and you do it really accurately, don't these two lines cross at one point? And that point is the answer that's going to go in here. Now I'm going to cheat and tell you what that point is, and you're going to believe me because I'm a mathematician, right? But in real life, aren't you going to draw it and make sure I'm telling the truth? So can you just pretend that I gave you that guy is 5 and this guy is 4, and that is the answer? But couldn't I check it just to be sure? Right, if 5, 4 is really the answer, shouldn't 5 add 4 be 9? And shouldn't 5 take away 4 be 1? Do you see it does work? Have I convinced you that I got it right? But can you see that if you did square paper, it would be exactly where the 5 going this way meets the 4 going that way, right? It would be nice and clear and you'd be good to go. Now, can you see that this method only really works with nice answers, right? I don't think I'd like to do a 4/3, 7/11 using this method, because I don't think I'm good enough to tell that fella. And I just thought of a cheat. Well, I'll work around. Couldn't I have went back to section 1 and used one of the blank ones there to draw that line and let WebAssign do it? So now that I've just thought of that, let's show you my cheat. Or let's call it a workaround to save us some issues, right? So you won't see it for a minute. I'm going to go back and draw those 2 lines and show you, hopefully, it working. Okay, so I'm going to use this guy, and the x plus y equals 9 crossed at 9, which is here, and 9, which is here, right? That was the first one, right? And then I'm going to go over here and do this, and I'm going to choose 0, negative 1, which was here, and 1, 0, which is here. Can you see that guy there? Whoops, well, I shouldn't have done that. Can you see that guy where my mouse is pointing? Isn't that pretty clearly 5, 4? I have no problems with you doing that. In fact, would that probably be a little bit easier than you trying to do it on a ruler and square paper and maybe being a little bit wobbly with your lines, for want of a better word, right? Are we good with it? In fact, if the answer was 3/5, 2/5, you'd probably be able to figure it out. You know, it'd be a little bit more accurate to read. So, yeah, I just decided to do something. Any questions so far about the strategy for how we're going to solve these questions? You're going to draw both lines, and if they cross over, there's going to be one answer and you're going to write it in. If they end up being parallel, you're going to write inconsistent. And if they end up being on top of each other, you're going to write equivalent. So see in that box there, you will actually write words. So if that was the picture, you're going to write the word inconsistent in this box. And if that happened, you're going to write equivalent in this box. You can also write in, there's other terms that they may accept, like dependent and so on. I don't know about you, but I need a joke. So I'm going to tell you a joke in a minute. Are you ready for a joke?
Yep.
We're all, including me, ready for a joke. Okay. So before we do jokes, because I like jokes, and although you haven't had me long, you're going to find out that one of my many idiosyncrasies is that I get distracted very easily. So when I get distracted, not that your kid is a bad distraction, I like distractions, it throws me a little bit. So one of the things that happens is that if a joke comes into my head, I have to tell you it so that it stops distracting me. And the second thing is I like students to tell me really bad jokes. So the rule of this game is they can be as corny as you like, cringeworthy, even better. The only thing is that it can't be unsuitable. So you kind of know, I think, what I mean by unsuitable, but it can't be sexist or racist or homophobic or all that, something that's going to make someone offended, right? We don't like those jokes. I don't want them. But I want to tell you a story about my role. Over 10 years ago, I had a class and I was asking them, anybody got a joke for me? And they always sit at the back. I don't know why, but when you were in high school, the guy at the back was the guy, and it's always a guy, right? The guy at the back, you had to watch him because he was the one that was just going to make life a misery for everybody, including me. So this guy at the back stuck his hand up and says, I got a joke for you. So I was a bit worried. I said, is this joke suitable? And we'd already done the suitable thing. And he swore blind that this joke was fine. This joke was suitable. And then he told the joke. And it was definitely not suitable, right? And I saw my career flash before my eyes. And I thought, okay, you got to do what you got to do. Make it a teaching moment. So I said, look, that joke's not suitable. And he swore blind it was. So I was losing this battle. You know it's not suitable. That was a sexist joke. That's just not right. People are offended. No. What, as we say in Scotland, it was water off a duck's back, right? Didn't stick, right? Couldn't get them to comprehend where our problem was. So I got desperate and I went and said, and this was the wrong question. I went and said to him, would you tell that joke to your mother? Right, you would think that would get me out of trouble. Do you know why it was the wrong question? His answer was, it was my mother that told me it. So I thought, oh God, how do I get out of this hole? And so I finally resorted to, my mother was alive at that point. I'm one of 10 children. So my mum was just over 5 foot, tiny little woman. I don't think I ever heard my mum swear in her life, right? Beautiful woman. And so I resorted to, would you tell that joke to my mother? So that's the threshold for unsuitability. So I want you to think of a 90-year-old little grandmother who's never swore in her life and think, could I tell that joke to that person? So that's our suitability rule. So from now, over the next 9 and a bit weeks, when I ask you for a joke, you're going to do that little test. So here goes. Are you ready for my joke? I should warn you, Scottish jokes are notorious for being quite macabre, right? So you're getting warning. This Scottish couple wanted a baby, and they tried and they just couldn't get one. And finally they had a baby and they were really happy. But when it was born, it was just the head. That's all they had, just the head. But it was intelligent and it was a son, and they loved him, and he grew up and he got to 18. And in Scotland, when you're 18, you're allowed to drink. So the dad says, come on, son, I'm taking you to the pub for your first pint of beer. And he picks up his son and he walks to the bar, and he goes over to the bar and he puts his son down, and he says to the barman, he's 18, give him a pint of beer. And the barman looks at him and said, but he's only a head. He says, look, he can talk to him. He says, just put a pint of beer in a straw and put it in his mouth and he's good. He knows how to drink. So the barman says, oh, okay then. And he gives him a pint of beer and puts the straw in his mouth, and the head, it drinks a pint of beer. And a miracle happens. The torso grew back. And so the guy went and said, it's not a head anymore. The guy said, look, get me another pint of beer quick. And his arms grew back. He says, I want another one. The rest of his body grew back. And he turns around to his dad and says, Dad, look, it's a miracle. My body has grown back. He says, I'm going to go home now and get some clothes and I'll be back in 10 minutes. And he opens the door and he walks out the pub and he crosses the road, and a bus kills him stone dead. Do you know what the moral of that story is?
Do not get drunk.
No. You should always quit when you're ahead.
It's smart.
Oh God, this is going to be a long quarter. Come on, I need to see. Right, let's use this as a teaching moment. I want thumbs up or thumbs down on that joke. Find the button that does thumbs up and
I
thumbs
get
down. I got enough.
How about this
Oh,
way?
I got a non-committal, right?
I
If you're
guess that's a
looking
good takeaway.
Okay. If you want to do thumbs up and thumbs down, on the bottom there, do you see a thing called reactions? It's like a little happy face with a plus on it. If you click on it, you can cry. You can thumbs up. You can, I don't know what, you can, you're right. Yes, I agree with you. That doesn't make sense. So if I am doing a lesson and I suddenly see an awful lot of, oh, I don't know, see what else I've got to play with here. If I see an awful lot of crying, I'm going to figure out that we have a problem. If I see slow down, it's going to mean, slow down, please. You're going too fast, right? If I see that, it's the equivalent of you saying, hey, I've got a question. Could I stop what you're doing and let me ask it, right? So they are kind of useful, right? Because some people, I understand, don't want to interrupt, but it is useful, right? Are we good? Did you like my joke?
Yes.
Okay. Do you want one more before we continue?
Yes.
Do you want another Scottish joke, or are they too macabre for you?
Scottish shows I can tolerate.
Okay. Scots guy and his wife go to America on holiday, and they go to a state fair. And they're watching this aircraft. It's a very old aircraft. The pilot's at the front and there's two seats, one after the other behind it. It's, you know, like a twin-winged, very old aircraft. And the guy takes people up and he just flies around the state fair and shows them it from the air. It's kind of a touristy thing. And the Scots guy is looking at that and thinks, that's great. Me and my wife should do that. She's all in favour of it. And so the aircraft lands and the people get out, and Scots guy goes over to the pilot and says, how much is it for me and my wife to do that aircraft thing? And the pilot says, oh, it's $100 each. Right, that's $200. And Scots guy says, oh, that's too much money. I'm not paying $200. So he says, come on, make me a deal here. And the pilot's looking around and nobody else is waiting to get on. So he's figuring out $100 is better than nothing. So he says, okay, I'll do it for half price. It's $100, right? $50 each, $100. But there's a rule. Scots guy says, what's the rule? He says, I don't want to hear one squeak out of you. I don't want a yell, a scream, any kind of noise. I hear any kind of noise, I want my $200. That's the deal. Scotsman says, not a problem, I can do that. And so sure enough, they make the deal, and the pilot gets in the front and the husband and then the wife go in behind, and he takes him up, and the pilot's doing the usual thing, and he's thinking to himself, no, he says, I'm not going to settle for 100. I'm going to make sure I get my money. So instead of just doing the little circle round, he starts doing crazy things. He flies towards a mountain, and at the last moment he veers off. Silence. He starts looping the loop, going round and round. Nothing. He goes towards the ground like they're going to crash, and at the last minute he levels off. Nothing. He turns the aircraft upside down and flies upside down. Nothing. So he finally gives up and he lands and goes over to the Scots guy and he says, well, a deal's a deal. It's $100. Gets his money. And then the pilot went and said to him, you know, it must have been really difficult for you to keep quiet. I tried everything to make you shout and scream. And the Scots guy shook his head and said, do you know, it was really hard. I almost screamed when the wife fell out. Am I going to get better than the middle, Dawn? Come on. Nothing? Oh. As I say, it's going to be a long 10 weeks. I feel so much better now. Oh God, Jamie Lynn's crying. Is it that bad? Sorry. I don't know. Maybe that was crying because it was that bad. It's good. Maybe it was just really bad. That's also possible. Okay, let's move on. We're still on that second section. What I'm just going to do is some more examples. Hopefully that'll get us quite good at these types of questions. I'll pick some of their questions. Right, this is similar to question 8. It's a 2x plus y equals 0. And it's an x take away 2y equals -5. I'll call it equation 1. I'll call this equation 2. And basically, I'm going to draw both of these and find out which one of these situations we're going to get. Okay, let's look at this one. This one is standard form. Oh, that's interesting. Yeah. I'm going to do the usual, choose x equals 0. So 2 lots of 0 plus y equals 0. And that gets me y equals 0. And nothing wrong with that. That's the origin. But there is a problem. And I'll show you it right now. Normally, wouldn't you choose y equals 0 for the second guy? Well, let's see why that's a problem. Well, 2x plus nothing equals 0. That makes 2x equals 0. That makes x equals 0. Oh. Have you noticed that if we do method 1, the x and y intercept, don't we only get 1 point? It ends up being the same point, in this case, the origin. Right? So we got to figure a workaround here. what do you think I might do then to find a second point? Because I need 2 points to draw this, right? I can't draw a line with just 1 point. I need 2 distinct points. What could I do?
One.
Why not? Pretty much anything will work, right? As long as it's not 0. Well, if I choose x equals 1, 2x plus y equals 0 becomes 2 lots of 1 plus y equals 0. 2 plus y equals 0. And y equals -2. So that gives me 1 comma -2. Do you see I've now got 2 points, 0, 0, and 1, -2. So you're going to just believe that I'm good at drawing, and this is square paper. And hopefully we'll see what's going on. So 0, 0 is easy. And what, 1, -2, I guess I better be a little bit lower then. 1, -2, that can be here, right? Imagine that's my first line. Okay, pretend that's bang on. So that would be what 2x plus y equals 0 looks like. Are we cool with that? Okay, now I need to do the second guy, and the second guy is x take away 2y equals -5. Okay, if I choose, I'm cutting some corners here, but see if I choose x equals 0, can you trust me that y ends up being 2.5? You can do that yourself later. Can you just trust me that's what you get? And then I'm going to choose y equals 0, and that's going to get me x is -5. And again, you can check that later. So I'm getting 0, 2.5, and -5, 0. So let's see what the two guys look like. 1, 2, 3, 4, 5. There's -5. So -5, oops, wrong direction. 1, 2. -5, 0 is about here. And 0, 2.5 is about here. So just double checking my own work. Okay, so this is x take away 2y equals -5. Would you agree that they cross here? Since I'm doing this by hand with wobbly curves and atrocious scales, I'm going to make a judgment call here. It looks to me like that point is probably -1, 2. Now, if you do it in square paper or if you do it in WebAssign, you'll get it perfectly. Now, if it is what I think it is, it should work here, and it does. So I can tell you for sure that that's the solution. It's -1, 2. So in other words, if x is -1 and y is 2, it works for these two equations. So let me do a check on that. 2 lots of -1, add 2. -2, add 2, 0. Yep. -1, take away 2 lots of y. So -1 take away 4 is -5. And yep, it works. You see it? It matches up. We need to see, in the short time that we've got left, I think we need to see one of these, right? What that looks like. And we need to see one of these. So I'm going to jump right in here and create some questions where this happens and then where this happens. So suppose we get y equals 2x plus 1, and I'll call that equation 1. And we get 2y take away 4x equals 2, and that's going to be my equation 2. So when you look at these two equations, they look quite different. In fact, isn't that a slope-intercept? And we could use our techniques for drawing that. And isn't this a standard form? And since I only have about 4 minutes, I'm going to do quite a lot of shortcuts that you're going to check. Right, let's do this guy. If you choose x equals 0, you get y equals 1. If you choose x equals 1, you get y equals 3. Are you happy about those? Would be 2 points I could use. Essentially method 1. Now, if we take 2y, take away 4x equals 2, couldn't we also use this method 1, which is make x 0 and make y 0? So again, I'm going to do the shortcut and you can check. If you choose x equals 0, y equals 1. And if you choose y equals 0, x will equal negative Can I check this? Y equals 0 is good. Negative a half. Okay. Again, imagine this is square paper. If I plot the point 0, 1, it's this guy, and then I plot the point 1, 3, then this represents the y equals 2x plus 1 line. If I do 0, 1, which is there, and I do negative a half 0, oh, you're going to have to trust me, but negative a half 0 is here. Can you see that it's the same line? Oh, I've just done inconsistent. Can you see that both these lines are actually the same line? And when you get that, we have equivalent. Okay. So actually, I kind of screwed up a little bit, but not too much. Haven't I shown you an example of what an equivalent would look like then? Right, you draw the first line and you draw the second line, and guess what? It's the same line. And that's equivalent. And in that case, wouldn't there be an infinite number of solutions? So I need to do one of these. So let's see if I can, in 2 minutes, do a very quick version of one of these. How about 2x plus 5y equals 10, and 4x plus 10y equals 40. If you wanted to do this guy, can you trust me that 5, 0 and 0, 2 are the points that are going to work? I'm making x equals 0 and y equals 0. If you choose this guy and you do the x and y intercept method 1 again, you're going to get the point 10, 0 and 0, 4. And if we do the first one, there's 5, 0, and there's 0, 2. The line goes something like that. And if you do 0, 4 and 10, 0, this would not be a problem in square paper. Can you see I've got 2 parallel lines? So what you have is inconsistent. So if you want to solve a system of equations by graphing, you will draw them using the techniques that we used at the beginning of today. And if this happens, there will be one solution and you'll read it off. If this happens, there are no solutions and it's called inconsistent. And if this happens, there's an infinite number of solutions and we'll call it equivalent. There are also other names for these. This, for instance, is dependent is another name for that.